we can go ahead and see from this photo really a website that will show us some of the descriptions of the airfoils and some calculations along with the different airfoil shapes. And almost every plane that you see flying today, one of these shapes can be found on that wing of that aircraft. So NACA was responsible for all of that. The North American F-86 Sabre was really around towards the end of the 1940s, featured swept wings and tail surfaces, and certainly the responsibility for that was from the Ames Laboratory, part of NACA. And so here's a beautiful example of that aircraft. And as you look at that, you should be able to see that the tail feathers are swept back, and so is the wing. And this solved a number of issues and made the aircraft capable of very fast speeds and very short turn radiuses, which allowed us to be at the forefront of fighter design back during the Korean War. We know that the Bell X-1 was a joint venture between NACA and the U.S. Army, and I have a great photo of Chuck Yeager's bird here to share with you. This is an example of that aircraft that finally, in fact, the one that you're seeing is really not, the tail feathers don't show the full flying stabilizer that they developed, but it nevertheless was the reason why that aircraft was successful. I met Chuck Yeager. I can't really call him a friend, but I've met him twice. In 2007, we were invited to show our Ryan Navion in the 50th anniversary of the Air Force, so I was able to meet Chuck there, and then again at Oshkosh in 1997. Very vibrant individual who has perfect vision and is still flying today at 88 years old and still flying jets. Okay, and then let's look at the Bell X-1A. Yeah, that stabilator made it possible for supersonic flight. Otherwise, the aircraft that we have today would not exist. The X-1A was another aircraft that was developed in conjunction with this one was particularly to develop more rocket engines and for higher altitudes, part of the X program. Another bird, the Douglas D-558, which was also used in developing airfoils, and let me get the D-558 out here, hang on a second. There we go. This was the Douglas Skystreak, and it was used for a lot of innovative test flights, both altitude and speed. And the next aircraft we have is the Convair XF-92A. That one was a hybrid, hastily built, but designed specifically to test the delta wing platform. I'm going to give you that picture as well. So if you click on that link, you'll see the Convair XF-92A. Now this is a model, but it's a good example of that aircraft, and with some reasonable detail. And you can see the delta dart shape. It almost looks like a lawn dart. The X5 was one of the forefronts of the swept back wings, variable sweeping. So I'm going to show you that photo. And from the picture you can see how the wings would sweep from full forward to full back. This allowed the aircraft during landing to fly at slower speeds, and then at higher speeds they would sweep the wings back, and it would allow the aircraft to fly at a much more efficient airfoil and speed. There's another aircraft called the D558-2 Skyrocket, and we're going to see that one attached to a B-29. B-29 was used to haul a number of the aircraft from the ground for testing, including the X-1. Here we can see the D5582 X vehicle being dropped from a B-52, from a B-29. We've got a few more here. I know we're running short on time. Northrop X4 Bantam was a prototype small twin-engine jet manufactured by Northrop Corporation. It had no horizontal tail surfaces, depending instead on combined elevator and aileron control surfaces that we now call elevons. And this was used for controlling pitch and roll attitude. So here's an example of that aircraft. You can see the swept wing, but there's no elevator here because the ailerons and elevator were mixed together for pitch and roll. We still had a rudder or vertical stab. Okay, the next one is a Douglas X3. The Douglas X3 was used to investigate the design features of an aircraft suitable for sustained supersonic speeds. And as you can see from that aircraft, it had a very small wing surface. In fact, the horizontal stabilizer is almost as big as the wing, but you can see that that aircraft was designed for speed. And we have the Navy F-11 fighter. That one was, you know what, I don't have a link for that one for some reason. Oh yes, here it is. Couple more, and we'll do some talking. The F-11F was one of the first aircraft that the Blue Angels flew, but it was also used by NASA for implementing what they called the area rule and other advances. But it was neat to see the Blue Angels use that aircraft. The X-15, of course, most of us remember from that period. The X-15 was really the forefront and almost got us into space. It was the fastest speed ever reached by a manned rocket-powered aircraft. And those of you that were around during that time may remember the X-15. But that got us close to the edge of space. The next aircraft was really the predecessor to the U-2 spy plane. It was called the ER-2. It was developed for a variety of high-altitude science missions flown over various parts of the world. So that was the predecessor to the U-2. And boy, you can look at that and really see very much the U-2. I'm going to get rid of some of my windows here so I don't crash. Okay. And then, of course, the SR-71 Blackbird, which was way ahead of its time, built in a very short period. It still holds the speed record. Some 3,000 miles an hour, Mach 3. It flew so high that they didn't even have to worry about missiles catching it. And you can see that this is really a lifting body. Roger Jacks, who lives here in Las Vegas, gave a talk to our Experimental Aircraft Association about the SR-71 Blackbird. It flew close to 100,000 feet in altitude at some 3,000 miles an hour. The little pointy sections you see out in front of the engines were used to control the airflow intake to keep it subsonic. And they had some problems with the computer back then, and that they would get some asymmetrical thrust, which would cause a yawing of the aircraft to the point where the aircraft would break up in flight. And so there were a number of ejections that occurred. There's still a number of aircraft that are being used today with regards to NASA's current projects. The one you're about to look at, the F-15 836, was a multi-segmented articulating spike attachment designed to reduce and control a sonic boom. And I've just got two more aircraft. And that's an F-15. So if you look at this particular photo, you'll see that it has a huge spike going out the nose. And this helped them to develop that control of the sonic boom. And the last one actually takes us back to the Wright brothers. Even though it's a current aircraft, we're going to see that the FA-18 Hornet, which is a jet fighter, was used to test wing warping, which we know that way back when the Wright brothers, that's what they used to control the turning of the aircraft. And now we're back full circle to this aircraft, which uses wing warping. Experimental for today's aircraft, but maybe a little more efficient. So that's what NASA's doing currently as a test. Okay, that pretty much gives you an overview of some of the important aircraft that were used during that period of the time. The last one is the FA-18 fighter jet that's currently being used on aircraft carriers for the Navy, but being used by NASA's Dryden Flight Research Center at Edwards for testing of the wing warping versus using ailerons for turning. Any questions? I'll try to answer them as best I can.